To Teen Academy, we are doing question 9. Okay, we're given a graph here and an equation for this graph which maps out velocity, and the values of t are on the interval 0 to 4. And the object, we're also given the fact that the object comes to rest at k. This is the graph of v versus t. It's given below. And at 0, the object's at its origin. So the first question asks to find the displacement of the object at t is equal to 1. So to find the displacement, since we're given a velocity equation, we must integrate to find the position equation, which we'll refer to as S. There is an error with the equation. After review, it should be negative t cubed plus 7 over 2t squared minus t plus 6. Okay, so now that we have that sorted, we will be integrating this equation. Now to integrate the equation, we'll require two integrals. The integrals we will be using are right here, 1 and 2, where the first integral, 1 is for a constant, where a is a constant, we have a dx, and it will become ax. And for the second integral, we have x to some power, n, where n cannot equal 1, becomes x over x to the power of n plus 1 divided by n plus 1. So we will use this for each one of our terms respectively. So the equation will become, for s at t, it's the position equation, t. So that is our position equation. And now, since the question asks for the displacement at t is equal to 1, we will just plug that into our equation. And you should find that the solution is 5 times 11 over 12, or 71 over 12. And that is in meters, and that will be our answer to the position or displacement of the object at 1 second. So for the second question, we are asked to find the acceleration of the equation in terms of t. So in this case, we will take the derivative of our equation, which I've shown below. And the derivative of any constant, like 6, is 0. So if we take the derivative of our equation, that will be the answer for our question in terms of finding the acceleration at t. Now for the next question, it asks, what is the greatest speed reached by the object before it comes to rest? So we can solve this, setting our equation to 0 and solving for the two roots of the equation. We can either use the quadratic equation, or we can factor this equation above. I prefer factoring, so we would need a term that adds to 7 and multiplies to 3. Negative 3 times negative 2. Okay, negative 3 times negative 2 is just positive 5. Oh, nope, 6, positive 6. So the way this works is we will rewrite our equation so that we still have the first term present, and the middle term will become 6x plus x, 1x, minus 2. And then we can factor this and collect like terms and So after finding your common variable between the two groups, we can write it out like this, where we factored out 1 in the second part, and we factored out negative 3t in the first part. And so we will take those two factors, write it out as 3t plus 1 multiplied by t minus 2. And then with this equation, we could say we could find our roots, and the roots for t are when the t makes the equation equal to 0. So one of our roots will be 2, and another one of our roots will be negative 1 over negative 3, which is just 1 over 3. So these will be our two roots. Because we are looking for the fastest value, we can omit the 1 over 3 and look for our velocity when the equation is evaluated at t equals 2. So if we plug t equals 2 into our velocity equation, you should find that your answer is 8 meters per second, which is the highest velocity reached before our object comes to rest. Now for the next question, we're asked, what is the greatest speed reached by the object on this interval? We can look at the maxima, the largest value on our interval rather, which is 4 seconds, and plug that into our equation, which should look something like this. Then when we evaluate, gives us the answer of negative 10 meters per second. And so we can say the greatest speed reached, greatest magnitude, is 10 meters per second. For the last question, we are asked to create an expression that represents the distance traveled by the objects while its speed is increasing. So what we know from our previous calculations, our t-intercepts, where our velocity is 0, is 1 over 3 acceleration, where acceleration is 0, where t is 1 over 3 and 2. We know that our system is at rest at t is equal to k, and we know that the highest speed is reached at t is equal to 4. And so we can say that the speed is increasing between the interval t equals 1 over 3 to t equals to 2, and because the object commences from rest at t equals k, the speed should be increasing again from t equals k to t is equal to 4. And then to write this as an expression, we would write the following, where we evaluate the lower and upper limits for v equals t. And for the second one, we need the absolute value. As we saw, the velocity was negative t dt. And here as well. Okay, so it is just the sum of these two expressions. And that is our answer.